Hello everyone, welcome to my YouTube channel. Today this is part 2 in B sharp in C sharp video tutorial series. In this video we are going to talk about a component from CLR. The component name is garbage collector. Yesterday we talked about the CLR. CLR is common language runtime, which is a key component under the .NET framework. So under the CLR there is another child component, you can say, that is garbage collector. So we are going to talk about this today, and we are going to learn about some key concepts and features, some performance considerations, and how to use it into the programming language. So let's start with the definition of this garbage collector. Garbage collector is a critical component in .NET framework as well as into the .NET core. It is responsible for automatically memory management. It takes the responsibility to maintain the memory allocation and deallocation, which developer is doing manually. The garbage collector in .NET is a sophisticated system designed to manage memory efficiently and automatically, which is allowing the developers to focus more on their task or the application logic rather than on the memory management. There are some key concepts and features under the garbage collector, which are automatic memory management, generations, phases of garbage collection, large object heap, concurrent and background garbage collector. Before jump onto the key concept, I just wanted to tell you there are two types of code you would see. One is managed code, another one is unmanaged code. Managed code would be that kind of code which is coming under the CLR, means whatever code you are writing using a language, that code would fall under the CLR because that code can be compiled by the CLR. So that is called managed code. But if you are using any kind of third-party library where you cannot make a change into the code, you just need to consume it. Okay. So that kind of code is called unmanaged code. So garbage collector basically responsible to manage the memory for the managed code. Unmanaged code, for the unmanaged code, garbage collector would not be knowing that how to manage the memory for that particular unmanaged code. So the first point is automatic memory management. So garbage collector automatically handles the allocation and release of memory for objects in the managed heap. Managed heap means whenever you are going to create an object, that object would be a part of managed heap, and that object would call as a managed object. So whatever code you are going to write, that would fall under the CLR. Under the CLR, you would be having managed code, and that managed code, inside that particular managed code, if you are going to create an object, that object would be called as managed object, and that object would be falling under the managed heap. So there is a sequence. Okay, under the there is a CLR, then managed code. Under the managed code, there is a managed object, and that managed object would be falling or being saved into the managed heap. Anything outside the CLR, as I told you already, outside the CLR boundary, garbage collector would not be able to manage that. The benefit of this garbage collector is like it prevents you or your application from the memory leaks or any other issue related to the manual memory management, such as double freeing of memory or accessing free memory. So it automatically works into the background to release the memory and make that particular memory available for the new objects. I'll give you a practical example in a while. Second point is phase of garbage collection. Whenever this garbage collector is going to run, it would run in three phases. First phase is mark phase, second phase is sweep phase, third phase is compact phase. Mark phase means in this phase, garbage collector is going to identify how many objects are still in use into the application. It would mark that. In the second phase, sweep phase, garbage collector would remove all the unnecessary objects which are not being used into the application anymore. It will just remove those objects from the memory, and it would make that particular memory available for the other new objects. Third one is a compact phase. In the compact phase, garbage collector would compact the memory and make the memory available for the other objects. Let me give you an example. I'll show you a diagram. I have created it for you. Let me give you an example. Let me open a notepad here. So let's suppose we have total memory of 20 MB. Out of 20 MB, let's suppose 12 MB is being used. Okay, so the remaining one is 8 MB. Okay, but you can see in this diagram, I can zoom it for you. Yes, in this diagram you can see the memory is allocated on different places. Okay, first it is like that. On the very first node, 2 MB is defined, 2 MB is allocated, then 1 MB free. Let me put F here, 1 BF MB. Then again 2 MB consumed, again 2 MB free, 1 MB consumed, then 2 MB free, then 2 MB consumed. So it is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12. So let's make it 12 MB. And how much it is used? 2 to 4, 1, 5 to 7. 7 MB is used. Now 5 MB is remaining. Okay. So if you see here, all these memories are being allocated in chunks. Okay. 2 MB is allocated here, then 2 MB is allocated here, 1 MB is allocated here, then again 2 MB is allocated here. Okay. Now you can see in this blue color, this is the free memory. Okay. This is 1 MB memory, this is 2 MB memory, this is 2 MB memory. In total, we have 5 MB memory. So if this memory keeps like this, so if there is a new object, we can put only 1 MB memory for a particular object in this location, and 2 MB memory for a particular object on this location, and 2 MB memory for a particular object on this location. Okay, but if we compact that particular memory, so how it would behave? It would collect all the free memories at a side and all the used memory at the other side. Okay, so all the used memory was 7 MB. It would put that 7 MB at a side. Let's suppose it is taking the left side for the used MB and 5 MB for the remaining side. Okay, now if an object comes with the memory of 3 MB, let's suppose you have created an object that requires a 5 MB space in the memory. So what you can do is you can do that garbage collector would assign 3 MB memory space out of this 5 MB. So let's suppose here it would assign 3 MB. 7 MB is already used. Then it would segregate it into 3 MB. It would allocate 3 MB to that particular object and remaining would be 2 MB. Okay, but in the earlier case, we cannot assign 3 MB, right? Because those were on the different places. It was fragmented. So that is why this in this it is a very important phase actually. Okay, so whenever there is a free memory in the phase 3, garbage collector automatically compact the free memory and make it available to be consumed by the other objects. Okay, I hope this is clear to everyone. And if you have any doubt or any question related to this, you can put into the comment box. I'll try to revert you as soon as possible. Let's jump onto our PPT. So this is these are the phases in the garbage collector. Now we'll jump onto the generation, how this garbage collector works. As I told you, there are 3 phases, but there are 3 generations also under the garbage collector. So garbage collector organize the object into the 3 generations: generation 0, generation 1, generation 2, based on their lifetime. Lifetime means for how much time that object is going to be available in the application. This generational approach optimizes the performance of the garbage collection process. Generation 0, it would be having short-lived objects. These are collected most frequently. Generation 1 would be having a medium-lived object, and generation 2 would be having long-lived object. These are collected very like less frequently. Okay. So I'll tell you how this generation works. I have created another diagram for you guys. This is the diagram. I have this is let me zoom it a little bit. So there are 3 generations, as I told you. So if there is an application, and inside that application, suppose there are 5 objects you have created inside that particular application. So as soon as the object is created, it moves to a generation bucket that is called generation 0 bucket, which is the initial generation in garbage collector. So once you create those 5 objects, these 5 objects will be moved to the generation 0 here. Okay, so you can see these 5 objects you have created over there, and that those are moved to the generation 0. And in the background, whenever garbage collector runs, so garbage collector will check how many objects are still needed into the application. So garbage collector will check how many objects are still needed into the application. So on the generation 0, whenever garbage collector is going to run, it is going to implement those 3 phases which I have told you recently. It is going to identify the objects which are in use in the application, sweep the unused objects, and compact the disk. So once garbage collector identifies the objects which are still needed into the application, it would identify it. Let's suppose there are 3 objects which are still needed into the application. Let's suppose these 3 objects is still needed into the application. 1, 2, 3. These objects are still needed, but these 2 objects are not required. Okay, so what it would do is it would just sweep these 2 objects and move these 3 objects to the second generation. So it will move these 3 objects which are currently in use into the application. It would move these 3 objects to the generation 1, and those 2 memories would be free. Okay, into the once objects are into the generation 1, again garbage collector will check how many objects are still running into the application from the generation 1. This process would work on the generations. The entire process would work on the generation 0, then generation 1, and then generation 2. So in the generation 1, a garbage collector would check how many objects are still running into the application and how many are not in use. So let's suppose one of the object, this object is still in use into the application, and 2 of these 2 objects are not in use. So what garbage collector would do, it would free these 2 memories, and it would move this particular object to the generation 2, because this object is a long running object. Okay, that is why it moves to the second generation, this generation 2nd. So garbage collector frequently checks this generation 0, free up the memory, and make that memory available for the other objects. Whatever remaining objects are left into the generation 0, it moves those objects to generation 1. The same thing it applies on the generation 1. Like in the generation 1, whatever objects are not in use, free it, and whatever is left or whatever object is in use, still in use into the application, move to the second generation. So these 3 generations are being catered by a garbage collector, and that is how it is working. Now question comes, why these generations are required? So whenever you are going to work on a large project, there can be n number of objects created, right? It will not be an easy task for the garbage collector to check each and every object if it can be released or not. So using these generations, garbage collector identify which generation object it need to release frequently. As I told you, generation 0 accessed very frequently by the garbage collector. So generation 2 will be having a long running object. So GC comes to generation 2 less frequently. As generation 1 is having medium long running objects, so GC comes to generation 1 more frequently than generation 2. And generation 0 is more frequently accessed by GC to release the memory as it is having short running or unused objects. So this is the reason these generations are required in the garbage collector. Now, how we can see the managed objects in the Visual Studio. Let's suppose you have created some object into your application, how you can identify the performance or how you can identify that particular objects. So we have a very good tool inside the Visual Studio, Performance Profiler. I have given a link over there also. You can see this is the link. You can go through this link for more details related to this performance profiler. And I have attached this one screenshot over there. I am going to show you how this works and how we can generate this kind of graph using the performance profiler. So let's move on to the Visual Studio. This is the Visual Studio. I have already created one application for you guys. I have created one form, and on this form I have created one button, click me, and there is one label. On this button click, I am creating an object of this GC example class, plus I have created a list, generic list of string type, and I am assigning one value over there, and I am just printing this value on a particular label. The label is you can see here, the label is here. So I'm just printing this value into a label. Okay, so now here I have created one object, assigning that particular object, and on that particular object I am creating a loop over there. Once this loop is finished, I am creating another object of this particular class, and that object I have not disposed anywhere. Now I am going to show you how you can check the performance profiler. So what you need to do is there is a shortcut Alt F2. Once you press Alt F2, you would see this kind of screen where you can select the project for which you want to execute the performance profiler. So I am selecting the startup project. Startup project means whenever we are going to a project, and whenever we are going to click on this start button, which project we need to start. So how we can set that? Go to this project here on the solution explorer, right click on the project. There is a option you would see, set as startup project. Once you click this, your project name would be in the bold font, and that is why you can validate, okay, this project is into the startup mode. So I have selected this startup project, plus from here on the top side, you need to change the this from debug to release mode, and you need to select this checkbox, .NET object allocation tracking. Okay, once you select that and click on this start button, you would see Microsoft Visual Studio is starting your diagnostic session, and your application UI would be pop up. Once you click on this click me button, whatever object you have created, it would be fired in the background, and you would see it is starting the diagnostic session for you guys. Once you start the process, then you would see these three kind of graphs. Okay, so this is the UI of your application. Whenever I click on this click me button, you would see there is a spike on this graph, object delta. Okay, so here you are seeing two kind of two color of graphs. One is green, one is red. So green indicates that the new object is being created over there, and the red indicates that garbage collector comes into the picture and it releases the memory from there. Okay, so I'm just stopping this collection. I'll show you how you can see the report of this, and in which generation your object would be. Each and every information you would see in this report. This report would take some time to generate. So once this report is generated, you would be able to see there is a pane having insights, allocations, call tree, function, and collections. Okay, so in this report, whatever area you would select from, like this, from here, it would generate the report in the below sections. So let's suppose go to this allocations. So in the allocation, you would be able to see all the data types, the small object heaps and the large object heaps. Okay, there are two kind of heaps, small object heaps and large object heaps. I'll tell you large object heaps in some time. Here, see this one. Allocation views shows the location of the object that are allocating memory and how much memory those objects are allocating. Call tree view shows the function execution path that contains object allocating much memory. Functions view shows process modules and functions that are allocating the memory. Collection view shows how many objects were collected or retained during the garbage collection, which I was talking about earlier, like generation 0, generation 1, and generation 2. So I have given this link. You can go through that. I'll add that link into the description also. So from here you can see there is a button click object. On this button click object, there are some allocation happened. Okay, so you can see there is a generic list over there, and there is a GC example class over there. Okay, and if you go to the function, so you will see there is a GC example over there, and as I told you, on this button click, you can see there is 2000 written over there, right? So what is this 2000? You can see here into the code. So this loop is running 2000 times over there. Okay, so 2000 times this object is going to be created, and this object is going to be created. Okay, if we come on to the collection, so on the collection side you would see the GC sequence and the generations. Your object is part of which generation? So you can see there is a generation 0, there is a generation 1. So this object was not released in generation 0, then it moved to the generation 1. And if it is not being released into the generation 1, it would definitely going to be part of generation 2. Okay, so here you would see the generation garbage collector type also, garbage collection region also, and the pause duration, large object heap size also. Each and every information you can check it from here. Okay, that is how you can verify the performance like of your memory, how you can manage the memory, or how garbage collector manage the memories. You can go through this link, particular link, for the more details. And still, if you have any kind of doubt or any kind of questions, you can put into the comment box. I'll try to resolve that as soon as possible. Next is large object heap. So as I told you, there are two kind of object heaps over there, small object heap and large object heap. As name suggests, small object heap would be responsible for small objects which is less than 85,000 bytes. Okay, the objects which are more than or larger than 85,000 bytes, those would be allocated on the large object heaps. And garbage collector treats the large object heaps differently due to the cost of moving large objects. So whenever there is a like huge file, if we want to move that particular file from one location to another location, or from one generation to another generation, definitely it is going to be costly for garbage collector, right? So large object heap is collected less frequently than the small object heap. As I told you, in the generation 2, there would be a large object heaps or long running objects over there, right? So those long running objects or large object heap would be accessed by garbage collector less frequently. I hope this is clear to everyone. Now we have two kind of garbage collector over there, concurrent and background garbage collector. So concurrent improves the application responsiveness by allowing garbage collection to run concurrently with the application thread. And how you can configure that? If you are working on .NET Core, so in the runtime config.json file, you just need to write this property, system.gc.concurrent is true. If it is true, that means it is a concurrent garbage collector. If it is false, that means it is a background garbage collector. And in the .NET framework, under the app setting, app.config file, there is a configuration section. Inside the configuration section, you would be having a runtime section. And under this runtime, you would be able to write this GC concurrent enabled false. Concurrent GC concurrent enabled false means it is not a concurrent garbage collector, it is a background garbage collector. If it is true, it means it is a concurrent garbage collector. Background GC means it is an extension of concurrent garbage collector that provides the better performance for the application for long running processes and performing the background collection on the generation 2 application. Okay, so whenever there is a large object or the objects which are available into the generation 2, so the background garbage collector would be able to manage that for the better performance of the application. While working with the garbage collector, there are a few performance considerations. So what we can do is we can minimize the allocations, use the finalizers, and there are some GC modes also we can make use of. Minimizing allocations means reducing the number of allocations. The variable allocations, we need to reduce that, and reusing the objects and using the value types wherever is appropriate. We should not do like this. We as string is a reference type, so we should not initialize the integer type values into the string, and then we should use convert that particular value again into the integer value and make use of it. No, we should initialize the value as integer, and we can make use of it. Finalizer means whatever unnecessary objects we are using into our application, we can destroy those objects using the finalizers. Finalizers are nothing but the destructor into the application. So whenever you are going to create a class, you can define the destructor over there, and whatever unused objects are there, you can just kill them from that destructor. GC modes means there are two kind of GC modes you would see. One is workstation, another one is server. Workstation, basically GC mode is basically works for the desktop kind of application or single user application, and the server mode, server garbage collector mode, basically works for the web applications which is hosted on a particular server or a server side applications. So these kind of things we need to take care while working on a particular application, and make that particular application more robust in terms of memory management. Now the question comes, how we can programmatically use this garbage collector. One, I have already told you, using the destructor, and another one is using the iDisposable interface. Let me give you an example, a practical example, and I hope that would help you to understand this concept. Let's move on to the Visual Studio. Let's close this, and on this form one, let's suppose I am creating an object of GC example class, right? So whenever I'm going to create an object of this GC example class, and inside this particular class, let's suppose I am creating any kind of object. Let's suppose this list object I am creating over there. Okay, so what I can do is, the first option is using the destructor. So how we can define the destructor? First of all, we need to define a tilde sign, then the class name. That is how we can define a destructor, and inside the destructor we can destroy the unused objects. So let's suppose while creating the object of this class, what we can do is, let's suppose we have defined a private property as list of string. I'm naming as obj, and on while creating the object of this class, there is a default constructor which is going to be executed. So inside this default constructor, I am creating an object of this list. So I'm creating an object of this list, and I'm performing any kind of operation on that particular list. Okay, so whenever this object is being used, or this object is not in used, so this destructor is going to be called automatically, and it is going to dispose this particular object. Okay, so how it is going to be dispose this particular object? So what we can do is, we can write a code over there. Obj, first of all, we need to clear this particular list, and we need to set that particular object is equal to null. Okay, so that is how we are killing this particular object, and this particular object is not more in use into the application. Second way is to use this iDisposable interface. So this iDisposable interface, if I click on this and press F12, so this iDisposable interface comes under the system namespace. In the very first class, I told you there are some namespaces available in .NET Framework. So this iDisposable interface comes under the system namespace, which is responsible for the automatic memory management under the garbage collector. So whenever we are going to inherit this iDisposable interface into our class, we need to implement this interface. So how we can do this? We can click on this iDisposable interface, press Control dot, and it would ask us to implement the interface. This is the first way. Second way, what we can do is, we can click on this iDisposable, right click on it, quick action and refactoring, and it would again show us implement interface. When we click on this implement interface, you would see one method would be automatically created, public void dispose. So this, inside this method, what we can do is, what we can check is, if obj is not equal to null. means if that object is having some value, it is not null, so then only it is going to execute some statements, or then only it is going to release the memory. The same thing should happen here also in the destructor also. First of all, it should validate if obj is not equal to null, then only it is going to release the memory. The same thing would be implemented here. The only difference between these two approaches is whenever I am going to use this idisposable method, I can call this idisposable or this dispose method after doing the operation here. Let's suppose I am doing some operation over here. Operation means any kind of logic I have written over there on this particular object. Here my work is done, and after that I want to dispose the object, so I can call this obj.dispose method over there, which I have implemented using this idisposable interface. Okay, and if I am not using this idisposable interface over there, and if I am using a destructor, so whenever this object is going to be created and that object's operation is done, the destructor is going to be called automatically, and it is going to be released that particular object we have defined under the destructor. So these are two ways we can make use of to release the memory using the garbage collector. I hope this is clear to everyone, and that's it for today. And if you have any kind of doubt or any kind of question, you can let me know into the comment box. Tomorrow I am going to cover the next topic, just-in-time compiler, and its key concepts like intermediate language, role of JIT compiler, and types of JIT compiler. That's it for today. If you have not subscribed the channel, I would request every one of you to subscribe the channel so that you don't miss any kind of video after turning on the notification. So please subscribe, like, and share these video tutorials so that it can be helpful for someone of your known. Thank you so much. Have a good day.